right, so now we're back for part 3, hopefully the last part, we'll see, of this lecture. And we're talking about using a truth table to determine validity. This is the case of 3 variables and 3 conjunctions. So once again, we want to determine whether an argument is valid or invalid. If Eddie goes to town, then Mabel stays at home. If Mabel does not stay at home, then Retta will cook. Retta will not cook. Therefore, Eddie does not go to town. So our first things first, we let P represent, we turn it into symbols, right? So we actually assign variables in this case. So P represents Eddie goes to town. Q represents Mabel stays at home. And R equals Retta will cook. So I'm going to block these out like this so that we can go back. Second, you create your symbolic table, taking the symbols from going from words to symbols. The first thing we see is that if P, then Q for our premise 1. But however, Mabel does not stay at home. This was a negated Q, but then it implies R because Retta will cook. So this is R. This is not Q. And Retta will not cook goes to not R. So that's our third. So this is our second premise. And not R is our third premise. And the conclusion, well, let's look up at the sentence here. Eddie does not go to town. Since we said Eddie goes to town equals P, this is negated to not P. All right. So if you notice, I'm looking at the statements from above, and I'm actually turning them into symbols. That's exactly what I'm doing. So Eddie is P, goes to town. Then I know that this implies that Q, because Q equals Mabel stays at home. For the first premise, I'm just going over it one more time, just in case you didn't get it. Since Q equals Mabel stays at home, but for the second premise here, it's not P because she doesn't stay at home. And R is Retta will cook. So this becomes not Q implies R. And then the third premise is, that's not the third premise. Retta will not cook. So we negated R and the conclusion is not P because Daddy does not go to town. Now, we take each one of these sentences for the third step to create our big conjunction statement. We take the first premise, conjunct it with the second premise, conjunct it with the third premise, implies the conclusion, which is not P. So that's how that works. And next, you create the truth table. So pause right now and see if you can create a truth table for this. So to create this truth table, I also want to take you guys a note a little bit here. I don't know if you did this. This formula tells us how many rows we're going to have in a truth table, 2 to the nth power, because n is the number of variables or the number of premises, or the number of variables in this case. It's 2 to the 3rd power, which means 2 to the 8th. You should have done, your heading should have looked something like this. I'm just going to go over it really fast. You should have done your knots here. So we had a knot P, we had a knot Q, we had a knot R. I would do those first, and then do your P, then Q. And then do this statement, P, then Q, and not Q goes to R. Another heading, the other heading after that, I'm going to put it down here, should have been P, then Q, and not Q implies R, and not R. And then you should have done your big statement. That looks something like this. I'm not even going to attempt to say it. because, you know, that's how life is. So this is not P. Now, the end result should have had eight solutions to it, and it should have been T, false, T, 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 T. And that is saying, I don't know what that is, I just did. That is if you use the cases true, 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 false. Oh, guess what I forgot? If you didn't, I apologize. I forgot my R, not P. This should have been true, true, true. And so if you look in the book, they actually give me just a second here. I forgot to put this in my notes, so I have to do a little bit of research. That's okay. It's just like doing a class. When I film these, I try not to be too perfectionist-like, or else I would never get them done. So that's why these are not used in real life. So your cases should have looked something like this if you did it in order like this. If you want to check it out, it's on page 129 in your book. So this is true, false, true, true, false, false, then false, true, true, and so on and so forth. So check out your book on 129. I'm going to actually reference this just because I'm trying to make this a little bit faster. Now, end result, no matter how you did it, you should have had at least one false statement in it. In my case, it was the second row, but if you did different than I did, it could have been located somewhere else. But this is not a valid statement because we don't have a tautology, so we'd say not valid in this case. This argument is not valued. All right. So next up, we have one more item we're going to discuss. And this is the one where it's a little bit more difficult. So this video is going to run over the traditional 10 minutes that I try to keep to, but that's okay because I want to only have a 3-part video for this lecture. So now we are going to discuss how to draw a conclusion just given premises. So this is your next objective right here. And I'm going to change this to something, let me stick to black just in case. So our objective is supply a conclusion to ensure validity when given only premises. Now, in order to do this, you need to remember the law of transitivity. And they discuss this in the book, and they use a Lewis Carroll poem that is actually used in it's been used in like art, popular music and stuff like that, where they talk about the horse loses a shoe if for lack of a shoe, or something like that with a horse, where they actually conclude that because there was a lack of a shoe, the war was lost. So it's pretty cool. But basically what it says is that if you start with the main premise of P implies Q, and then you take Q, the consequence becomes the new antecedent for the premise 1, for the premise 2, and it goes to a new conclusion. Then you can take the antecedent of the original premise P, or premise 1, which is P, and the consequence of the second premise, and you can come up with the conclusion. So basically, P implies R. So I'm going to say that again. If P implies Q and Q implies R, then you can take the original antecedent in premise 1, and it can imply the consequence in premise 2. All right, so that would be a valid argument because of this law of transitivity. Also, when you do these, you need to remember your conditional statements. So for example, what I mean is if you have P implies Q, we know that its converse is where you just flip it around. And that's the converse of the conditional statement. And I'm forgetting the name of these. So then the inverse of a conditional statement is not P implies not Q. So this is the inverse. And then remember we spoke about the contrapositive where we flipped the conditional statement. Q implies P, and then we negated both of them. So not Q implies not P. This is the contrapositive. So whenever we talked about this, we also knew that P implies Q is equivalent to its contrapositive because they have the same truth table end result. Also, we talked about the converse of if P then Q, which is Q then P, is equivalent to its inverse, not P then not Q. All right, so that was a big deal right here. So you need to know all these things in order to supply a conclusion to ensure validity. And there's a couple more steps that we are going to have to do with these, but the basic idea is the same. All right, we have premises, so the goal is to come up with a conclusion that's logical. All right, but the difference is now we are going to do a couple more things. So here we go. Let's look at this example. I know some of you had a question about this on Friday, so I hope this clears it up. So here's the premises. Premise 1, babies are illogical. Premise 2, nobody is despised who can manage a crocodile. Premise 3, illogical persons are despised. So from this, we need to come up with a conclusion too. That is our goal. All right, so your first step, because we don't have if-then statements, because we're still going to do the same basic steps of, letting P and Q and S and R equal these different statements, and then we're going to turn it into a symbolic premises. We're going to do some maneuvering to see if we can come up with a conclusion. But before we can do that, we have to turn these statements into if-then form. So the first one's pretty easy. If you are a baby, then you're illogical. Babies are illogical. So you can say if you're a baby, then you're illogical. Second premise is a little bit tricky. Nobody is despised who can manage a crocodile. Who is the big statement here? Whatever's after who is your if P because it's a condition. So if you can manage a crocodile, then you are not despised. So we had if you're a baby for premise 1, I forgot to mention this, and then premise 2, if you can manage a crocodile, then you're not despised. The third premise, illogical persons are despised. Well, if you're illogical, then you're despised. That's pretty easy too. So we turn those into if-then statements. From there, we do the same thing that we did in previous truth tables to figure out if an argument is is valid. We let P equal a baby. We let Q equal your logical. We let I'm going to let Q equal illogical. They don't listen to my notes. That should be illogical. R is you can manage a crocodile. And S, you are despised. So from there, we know that in premise 1, we have P, then Q. In premise 2, we have R, then, what did I say S was? I'm going to let S equal you're not despised. So then we have R is equal to S. So put a little not despised right there. I knew there was a little bit of a typo. I don't like the way it looks. So S equals you're not despised. So this is R goes to S. And then I said right here, you are logical, which I let Q equal you are logical, then I let S equal you are despised. However, S equals you are not despised, so we need to negate S. So this would be not S. All right? Because I let S equal you are not despised. And the premise 2 says you are despised, so this is actually a negation of S. All right, so take this off right here, and this is actually what S should be. So that's the little typo. Sorry about the typo, guys. All right, so that's the third step is now with these letters and statements, we write each one of these premises as a logical statement. So premise 1 is P. P implies Q. R implies S. I have a lot of typos here, so I'm going to take these out and do it on the side. Just cross these out. So I'm going to say my premise 1 is P implies Q. Premise 2 is R implies S. Premise 3 is Q implies not S. Just like that. All right. So now, I express these symbolically using my if-then statements. My fourth step is I'm going to use the law of transitivity. All right, and remember, law of transitivity says that P then Q, Q then R, then R or P implies R. All right, so that's just a little side note right here. So how can I do that with my premises? How can I express this? Well, if you notice, I have P then Q right here, and then I have Q right here. So what I can do is I can actually take my premise 3 and move it up. So premise 1 would stay where it's at, so P then Q. Then I would write premise 3, which would P implies not S. And then my premise 2 would just go right here. R implies S. So here I'm super close. I have P then Q becomes my new antecedent, then it implies S. And here I have R then S. How would I make this a not S right up here so that I can use the law of transitivity? Well, pause and see if you can figure it out. If you said take the contrapositive, you would be right. Because if you remember, R then S is equivalent to its contrapositive, which says not S implies not R. Let me write that over here. Actually, so if you remember correctly, I'm going to repeat this one more time. The contrapositive of R then S are equivalent. So this says R implies S would be not S implies not R. So this is the contrapositive and they're the same. So I can substitute this in for premise 3. So what becomes new here is premise 1 would stay the same. Premise 3 would also stay the same. Premise 2 would be substituted with the contrapositive, not S implies not R. And I can come up with a conclusion based off of that using transitivity and the contrapositive. What you do is now you take P and it implies something, but it implies the consequence of the very last premise, which is not R. The fourth step, the very final step, because this was actually the fifth step, sorry, so this is the sixth step, I rewrite P then Q, not R, in words. So I know that P equals babies. What did we let P equal? We said, you are a baby. And R was What did we say R was? Oh, I can't find it. Ha 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 ha. R as you can manage a crock. So if we wanted to write P implies not R in an if-then statement, we would write if, and then we would put in P. If P, then not R. And then we would just say if P, which is you are a baby, then not you can manage crock. So the final statement would be, if you are a baby, then we'd have to negate you can manage a crock, and that would be you cannot manage a crock. So this would be your valid argument. If you are a baby, then you cannot manage a crocodile. And that's it for this section. This last one is probably the hardest thing that you have to do in this section, and it will require a little bit more thought. Use your premises and the law of transitivity to move around your premises. See if you can find equivalent statements using your contrapositives, inverses, or converses with your original conditional statement or whatever you have. Just look for the pattern, and then once you find your conclusion, P implies Q, like right here, put it into words. And sometimes you'll have to negate sentences. All right. In the book, I will say that they did something wonky, and I do it completely different. I don't take the negations right off the bat. I just let every variable equal what it originally equals, and then I negate from there. All right. So that was the one typo I had. So that is that we're done with this section 3.6. And next up, we're going to go through problems in the next class. I'll see you later. Bye.